2.2 Day 1, more on functions and their graphs. Our learning goal is still that you will be able to build functions that model relationships between quantities from existing functions. So in this lesson, we're going to look at even or odd functions and how to determine if a function is even or odd. So first, let's start with even. And even functions have what we call y-axis symmetry. And what that means is when the function is graphed, it is symmetrical over the y-axis. So here's our y-axis. And a good example of this is the parabola that has a vertex on the y-axis. And so this is called an even function if the y-axis is the symmetrical line. Now, when you're looking at an equation, what that means is your negative values should be the same, or your negative x values will have the same y values as your positive x values. So if you notice on this parabola, the left side is identical to the right side. So that means that, for example, if this ordered pair was -3, 5, then this ordered pair, just because I make the 3 positive, 5 should still be the y-coordinate. So that's what that means. So in an equation, let's say they gave us x to the 4th power minus 2x squared. What that means is if you make all your x's negative, then your equation should not change. It should stay the same. So let's see if it works. So if I make all my x's negative, and then I simplify this, negative x to the 4th power is still positive x to the 4th. And negative x squared is still x squared, and x squared times -2 is still -2x squared. So notice that the blue equation and the yellow equation are exactly, this equation, the original, and f negative x are exactly the same. Okay, so that is called y-axis symmetry. So basically, even if you change your x's from negative to positive, your y values or your f of x should not change. Okay, our next type of function is an odd function. And odd functions have origin symmetry. And that means that the origin, which is 0, 0, is now the symmetrical point. And usually the graphs look something like this. See, it's symmetrical over the origin. So if this point was 1, let's make it 2, 8, then what this is saying is this point If I make this x -2, what do you think is going to happen to the y value? Then it's going to become negative. So origin symmetry, when you plug in a negative, then your answer should also be negative. So as an equation, if you had something like this, f of x, and you make it negative, you make all the x's negative, then when you cube a negative, it becomes negative. And when you do -3 times negative x, this becomes positive. So if you notice, the signs changed for both of the parts in the equation. So that means that f of negative x is equal to negative f of x. So it's like the opposite. And all the signs have to change. Now, if you had an example like this, and I change the x's, let's make this we'll just make it x squared minus x. All right, and then we would have gotten x squared, and this will become positive x. Now, if you notice, this term changed, but this one didn't. So anytime that only one changes and the other doesn't, that is neither symmetry. So to recap, to give you a summary, and put it over here. Even functions, all signs stay the same. We'll put that means when you do f of negative x, odd functions, all signs change, and neither signs flip-flop. And right here, we better write the word signs so that you'll know. All signs are the same. Okay, let's look at this example. We're going to determine if each function is even, odd, or neither. So let's start with example A. So remember, if it's an equation, you can always graph it if you have a graphing calculator to determine it. And just draw the graph and you can tell me if it's even or odd. Just sketch the graph so I'll see it. If you don't have a graphing calculator, you plug in negative x, and we're going to see what happens to the signs. So this one changed. It's negative x cubed plus x. So if we use our little check off, this change, this change. So since they both changed, this is an odd function. All right, let's try B. All right, squaring a negative still makes it positive, so it's x squared. And raising something to the fourth power still makes it positive. Okay, this stayed the same, this stayed the same. Since they both stayed the same, this is an even function. All right, C. Now when it's a graph, you look at the y's. See how they stayed the same? Then this is even. And you can tell because the y-axis is yours. This is y-axis symmetry. Okay. D. Now notice what happened with this y and this y. They changed. And here's your origin. So it has to go through 0, 0 for it to be. So this is origin symmetry. So this is a odd function. And then finally E, well, it's not going through the origin. The y-axis is definitely not the symmetrical line, so this is neither. Now we're going to go over some key concepts, key vocabulary words that you need to know. These three we use when we're describing functions. We can describe them as increasing, decreasing, or constant. And when we're doing these descriptions, you only use open intervals. That means no brackets. And you only look at the x-coordinates when you're doing your descriptions. So if you had a graph, let me draw a graph like this. Actually, I'm going to do this. Okay. And it's best to read your graph from left to right. So like on this left side, and I'll try to highlight it. So from this point on, we can see that the graph is constant. So when you describe it, when you describe where it's constant, you go left to right. So you see this arrow on the end? That means negative infinity, because remember, we're only looking at the x-coordinates. So we would say it's constant from negative infinity, and then it stopped being constant at negative 1. No brackets, remember. Okay? And then where the graph is, then it started decreasing. So it probably decreased, starting at negative 1 to 0. And then it also decreased at, see this point right here? See where the graph is decreasing? So from here on out, the graph was decreasing. So that would be from 2 to infinity. So there were 2 places where it was decreasing. And then it was increasing just in this spot right here. I'll do it in yellow, which was from 0 to 2. So that way your whole graph has been taken care of from negative infinity. So here's negative infinity. Here's positive infinity. So and we just go straight across. From negative infinity to negative 1, it was constant. From negative 1 to 0, it was decreasing. From 0 to 2, it did an increase. And from 2 on to infinity, the graph was decreasing. So hopefully you understand that. Now, relative maximum. A relative maximum, when they say relative, that means that you're looking close to where there is a maximum in the graph. So if we use this same graph here, the relative maximum, let me get a black so you can see. This point right here is 0, 0. Your relative, and then this point right here, we'll just say is 2, 5. So when they ask you what the relative maximum is, that's this value. If they ask you for the relative minimum, that's this value. So in this case, my relative maximum is 5, and my relative minimum is 0. Now, they may ask you, where did it occur? Or the number at which f has a relative minimum. Then that's when you say it has a relative minimum at 0. If it asks you for the relative maximum, you'll say it has a relative maximum at 2. For example 2, our last example, we're going to find the following characteristics. So first, let's do domain. Remember, domain is left to right, and you look at the 2 ends. So you're going from negative infinity, and we have a stopping point, which is 6, and it is included. Our range is up and down, so we're going from negative infinity, and 1 is the highest. The zeros, which are also known as the x-intercepts, are where it hits the x-axis. So you see it hits it at negative 3, 0, and 3, 0. When you see something like this, f of 0, that means the y-intercept, which is just 0 and 1. The intervals where it's increasing. So remember, when you're doing increasing and decreasing or constant, you only look at the x-coordinates. So it's only increasing, and I'm going to use the yellow, from negative infinity. See that? And it stops increasing at 2. Or excuse me, negative 2. Okay? I'll erase that so you won't get confused. And then it was decreasing. It started decreasing when x was 2. And then it stopped decreasing at 6. So you would say 2 to 6. And I'll erase that. And then it was constant when x was negative 2 to 2. So this part right here. And I'll erase it so you won't get confused. F of 4, that means when x is 4, what is y? So when x is 4, y is negative 1. And then for I, it says values of x for which f of x is negative 2. F of x is y. So if we look along here, we actually have two x values where x is negative 2. We have negative 5 and we have 5. And then the last thing we're going to determine is this function even, odd, or neither? Well, it can't be odd because it doesn't have origin symmetry. It almost has y-axis symmetry, but on this side it stops, and on this side it's going to negative infinity. That means that it is neither. And that concludes this section.